Hello to everyone. This is the second part of the function, or you say second lecture, and also second section. As this is also the part of 11th class level, as we in 12th class we will make a revision. So we will go through in this lecture even and odd function, also periodic function. So now let's start. Nature of function, which is the part of section 2. In 2.1 even function, in 2.2 we'll discuss odd function. So what is even function? So let me zoom it out. So what is even function? This is a function defined such that if f of minus x is equal to f of x, then it is said to be even function. As you know, this part is important here. F of minus x equal to f of x. Wherever there is a x in the function of fx, if you replace this x with minus x, then and we find fx itself, then the function is called even function. Okay. So an even function satisfies f of minus x equal to fx, possesses same values of x which are equal in magnitude and opposite in sign. So, for example, f of minus 1 equal to f1, f of minus 2 equal to, what do you say? F of minus 2 equal to f1, f2, f of minus 3 equal to f3. So here f of minus 3 equal to f3 and so on, means f of for any value of x, the negative and positive on the same domain, you will find the same result, same output, means same range. So if you give any negative input of that same positive, you will get the same result what is in positive. Fine. Let's we take some example to understand the even function. As so, let fx equal to x square. Suppose x square is any function, and here if we say f of minus x, then what we will get, that is also minus x whole square, and that is the same x square, which is nothing, it is fx. So this is the function fx, f of minus x equal to fx. Here what we find that f of minus x equal to fx, which is the even function. So which satisfies the concept of even function for every value of x belongs to R, as this is the domain of this fx. Means in entire domain, if you find this, so take some more examples over here. So in this f of minus x equal to fx, which is the definition of even function. So what we conclude? We conclude that all the even function, means graph of the even functions, are symmetric about y-axis. These are the symmetric about y-axis. Let's see some example, as like f of x, what we said, f of x equal to x square. If you see the graph here, then f of x, that is x square, this is even function, and this graph is symmetric about y-axis. If you see this part of the graph, this is here same, and here this is also same. These are the symmetry with respect to y-axis. See, this is symmetry with respect to y-axis. This is symmetry. So the symmetry, what do you mean by symmetry? As like here, note point. If you see, this is this as a note point here. If you see, the graph of fx equal to x square is symmetric about y-axis. Not only this one, every even functions are symmetric about y-axis. So you have to clear this term symmetry. Symmetry is very important in mathematics. So what is symmetry? Symmetry is a word that it means alike, as like, same like. Means, example, human body is symmetric about its vertical axis. If you see, left hand, right hands are same, and left leg, right legs are same, left eyes, eyes are same, so on. So this is the symmetry. Symmetry, we usually discuss this word in chemistry also, in symmetric results. Isomerism chapter, you have discussed symmetry, and many other places also we see symmetry. So entire uh, universe is symmetrically placed. So the Michelangelo thought is also beauty lies in symmetry. Anyhow, come to the point. So symmetry, what is symmetry over here? So if you see, this is graph is here, this is x-axis. If I make this any graph or y-axis, and let fx define in its domain such that fx is just like here, this is the graph of fx, and if we find the graph placed such a way that here also the graph goes like this way. Suppose the graph goes like this way. It means if this is the value of x equal to a, this is x equal to a, here that is x equal to minus a, then graph is symmetric. It means let this point be here c1 comma c2, right? And here if you see, this point also comes on the same point like this. If you see, at same distance, that is, it means this one is c1, and here that is minus c1. This coordinate becomes minus c1 comma c2, right? Minus c1 comma c2. So c1 comma c2 and minus c1 comma c2, these points suppose are same here. These point will be same over here. This point and this point means this is the height of this point, that is c2. The height of this point is c2, say here c2 at c1 and here at minus c1. So this height is same. This means that this function is even function. So every even function, this shows that this is even function. Every even functions are symmetric about its y-axis. Okay, it's fine. Let's take some more example. Like here, this is you see this one. This is the fx equal to x square. Fx equal to x square here, and here if you see this one, that fx equal to cos x. In trigonometry, if you come, then cos x is also even function. Here that it means cos x is symmetric about y-axis, and another partner, that's partner, that is means there is a reciprocal, that what you call sec x. This is also even function. If you come in trigonometry, then what do you find? Cos x and sec x, both of them are even function. Okay. Let's we take example. We define fx as here x cube, right, for x not equal to 0, and 1 for 1, you can say somewhere else here, x not equal to 0, and 1 is not defined. You can check it out like this way, that just only for x cube, right? Fine. Or better just fine. So here at x equal to 0 is not defined. So as this is, you have to check whether this is odd function, fx equal to x cube, as you are saying here, x cube. Let's we draw the example, draw the graph. So here what we say, at x equal to 0, function is not defined. At x beyond 0, right side and left side, this is the graph. So this is y equal to x cube. Fine. As whether this is odd function, so the answer will be yes, it is odd function. Correct. Now if we make the same question like this way, suppose let's we take a question fx equal to, we define like this way, x cube for mod x is greater or equal to 1. Correct. And here that is what we say 1 by 2 for x equal to 0. Now you have to test whether this function is odd or not. So let's see. This is the graph of this function above what we are going to discuss. Mod x is greater than 1. So if you see mod x is greater than 1 means we have to think about greater than 1 and less than minus 1. So beyond 1, what we get here, we have to draw the graph like this way, y equal to x cube, because between 0 to 1 graph it's not clear, and between minus 1 also here the graph goes like this way. Beyond minus 1 also graph is there, it's okay. So what about 0? At 0 the graph is here somehow 1 by 2, graph is 1 by 2. Is this function odd? No, this function is not odd. This is not an odd function. This is not odd, right? Let's take some more example. Achha, despite of this, for odd function, for even function, if we say like this way, if we define the function any like this, let fx equal to, what we say, x square for you say, let me say this function x square for x is greater or equal to 1, right? And that is, you can put mod x once again, and here that is this, and 1 by 2 for x equal to 0. Now we have to test whether this function is odd or even, or means of course it is even, it may be somehow even, as the student can recall even. So whether we have to test, verify whether this function is even or not. So let me draw the graph first. What happened here, while drawing the graph, what we see, beyond 1 we can draw the graph like this way, x square, like this. It means at x equal to 0, this part, this will be filled over here, because at 1 the result is there, and at minus 1 also 1, and graph goes like this way. But between minus 1 and plus 1, what is at x equal to 0? At x equal to 0, the result is 1 by 2, you know, this result is 1 by 2 at x equal to 0. So at x equal to 0, what we get? 1 by 2, this point is there. This point is also 1 by 2, means this is also the part of this graph. This is also the part of this graph. Okay, this 1 by 2. So is this even function? Is this is even function? So what the answer will be? Yes, it is even function. Even function. Yes, it is even function. This function is even. But despite of x cube graph, if you see that the result was, how the result was there, here what we see that the function was, let's we take once again that same example, fx equal to x cube for x mod x is greater or equal to 1, and that is you say 1 by 2 for x equal to 0. So when we were drawing the graph like this way, let me draw here to clarify this one. This is x-axis, this is what I call y-axis. So this is x equal to 1, here 1, here the graph is a cubical parabola, grows like this way, and this is minus 1, this is also minus 1, the graph goes like this way, right? And at x equal to 0, what do we call? At x equal to 0, what the result will be? That is, once again, if you see, this is 1 by 2 at x equal to 0. So what we say here, somewhere here 1 by 2, right? This is 1 by 2 at x equal to 0. So which is the part of the graph? Here, this is also the part of the graph. Now, despite of this, that was even function, here it is not an odd function. It is not an odd function. In this case, this one is not an odd function. Why so? Because for the odd function, if it defines at x equal to 0, then here the value should be 0. Then only we can say the function is odd. If you change this result to from 1 by 2 to 0, then the result will become odd function. Then the result will become odd function. Otherwise not. Otherwise, in this case is not odd function. So let's have some property of odd function and even function. Okay. So property of odd and even function. Let's say the JEE syllabus, that is sum, difference, product and quotient of the functions are there. So in the sum, if you add even and even function and odd function, then undoubtedly the results are correspondingly even and odd respectively, you see. But here, if you add even and odd function, mind this point, even and odd function, then the result is neither even nor odd. That it means result is neither even nor odd. It's depend upon which one has greater part of the range in which domain. So you can't say anything on these two cases. So similarly, if you here add, subtract also, or you make the difference of even and odd function, so even with even and odd with odd, you get the result will be even and odd respectively. But in different even and odd, which is neither even nor odd, you can't say anything. Can't say means the result is neither even nor odd. It is not necessary that every function be even and odd. The function may or may not be even, may or may not be odd. And a function, one more thing I want to tell about here, that no functions are there which are both even and odd simultaneously, except fx equal to 0. Fx is the equal to 0 is the only function which is even and odd simultaneously, right? Besides any other functions, if you define here or put the definition according to as per the rules of function, you find that it is even, it is odd, maybe neither even nor odd also. Let's say for product, so if two functions are even, then the result is also even. If the two functions are odd, then the result is odd. But if any one of the function is odd and the rest of the functions are even, then the product will be odd. Okay, fine. So let's see some more in division also. The same pattern of product in multiplication, the division also gives the same result. So the quotient is also the same type here. If you see this one, that even divided by even, the result is even. Even divided by odd, the result is odd. Odd divided by even, the result is odd. Okay. And here similarly, odd divided by odd is equal to even. To understand these knowledge about this one and about here in the product and division, so even you just consider as to put in memory, even you just consider as positive and odd you consider as negative. So what is the product of positive into negative? The contrary sign gives the negative result and the same sign gives the positive result. So here the same, you see here even into even, that is same sign. Here also same sign gives the same positive result. So that's why even. And contrary sign, this one gives negative. In division also the same thing. Now, as according to as per definition, f of x plus f of minus x equal to 0, f is odd function, and here what we see that fx minus fx, so you just transpose and get the same result. These two results are same, and it is a very important to select the even and odd function also. And one more thing you have to notice over here, that is very important, that is the note point here. The square of even or an odd function is always even, because squaring the odd function what negative pulls out, that making the square, making the even power, or making the even function, here the result will be always even. So making the square of negative sign means minus 1. If you see minus 1 whole square, what is minus 1 whole square? That is plus 1. So of course it becomes positive, right? So that's why square of any odd function or even function, of course even. So squaring, square is the term, means power 2 is the term, negative makes in positive. So squaring of any odd or even function, the result is even function. Okay, fine. Now let's we move on new topic, that is periodic function. What is periodic function? So to understand the concept of periodicity, we have to focus such that, that is a definition of the period, that is f of, what is the definition of the period, basic definition of the period is f of x plus t is equal to fx, is equal to fx, where t is the period, t is period of fx, period of fx. Okay, fine. And t is the least possible positive value, t is the least possible positive value, that is the period of this function. In physics, usually when we discuss about period, that is the time period, but in mathematics, period is a very general term, which also an example of time period. But here f of x plus t is the any real number over here for any function. Usually all trigonometric functions are periodic in nature, all trigonometric functions are periodic with nature. And here in the period, one more thing we will introduce later on, that fundamental period and period. But in general, if we say period, then by default you have to consider as fundamental period. For example, all trigonometric functions are periodic with period 2 pi, although fundamental period is 2 pi, and of all trigonometric function except tan x and cot x. Tan x and cot x fundamental period is, the fundamental period of tan x and cot x is pi, whereas fundamental period of sin x, cos x and their reciprocal, cosec x and sec x, that is 2 pi. This is the fundamental period. The period may be 4 pi also. Okay. So here, this is the definition of period as f of x plus t is equal to fx. The smallest value of t is called the period of this function. So the positive t should independent of x for fx to be periodic. In case t is not independent of x, fx is not periodic function. So t is means some constant type term, means t is any real number in the function. Let's we take some example. If we see the definition graphically over here, then what we find that here, if you see, this is the graph of a sin x. A means that is the amplitude here. A function is said to be periodic if graph repeats itself after a fixed interval with the width of that interval called its period, and that width is the period. Here, as like in this graph, if you see that, what is the width of this function, what is the width of this graph? The width of this graph is here 2 pi entire. Within this 2 pi, it completes its one cycle. If you see here, it completes entire one cycle within this 2 pi period. So this I have overlined this black portion, that is repeating throughout here. That is later on what we see, the same, it is repeating. Now if you see over here also, here that is the same pattern is repetition, same pattern repetition. Here if you see once again, here that the pattern will be same like this. Okay, so this same pattern is repeating over here. Anyhow, so this is the A sin x. So if you see that A sin x, A is the amplitude over here, and sin x. So if you take some more example here, let's see. Let me take some more example to understand the period. So if we draw the graph here, let me draw the graph as like this one. This is x-axis, this what I call y-axis. If we draw the graph like this way, like this, and come to the point here, although this will not to be considered as a function, so we haven't to go like this way. So we have to make some another type of graph like this. Like this we make the graph. Let me make the graph like this way. Okay, and here the width is at x equal to some a unit. So if we find the same pattern like this from 0 to a, then what we conclude over here? Then in other way, what we say, the graph goes like this way. In other way, the graph goes like this way, right? So same pattern graph is repeating over here. The graph goes like this way. It's okay. Graph goes like this way. Okay. So if the width is a over here, if the width is a, we say this length is a, then what we call, let this be function y equal to fx, and the width is a is over here also, and this is also the length a, although it is negative a. So here we find this is the same pattern of the graph here. Then what we conclude, that the period is a. So if this a is the fundamental period, within this period graph repeats its own behavior, means it's attaining the same value here. So if you see some standard result of this functions, that here I had made the table, a standard result of periodic function. So if you see over here, that sine to the power nx and then cos to the power nx. So you see this part, sine to the power nx and cos to the power nx. The period is pi if n is even. This is the important, if n is even. In this case even, the period is pi. Otherwise, and sec x to the power nx, cosec to the power nx. These are the reciprocal of cos and sine respectively. So in general, sin x cos x period is 2 pi, and if n is even, then its period is here pi. Otherwise 2 pi, correct? So mind this point, when the result is odd, the period is 2 pi. Okay. Now, but in tan to the power nx and cot to the power nx, whatever the n is, it doesn't matter. It's okay. So n is either even or odd. Period is always pi. Period is here pi. It doesn't depends on n. But if we put here mod of this any trigonometric function, so mod of any trigonometric function t of x, any trigonometric function, this is the mod of any trigonometric function. We say, let's say t of x is the any function, t of x is any trigonometric function. If you put here mod t may be sine, cos, tan, sec, cosec, any, then the period is here pi. The period is pi. Period is, you say, pi, right? But mod is there. Here x minus gi of x, this is fraction part of x. Let me make the diagram. Let me draw the graph over here. So the graph of fx is equal to gi of x, you see. This is let x-axis, this is what you call y-axis here. The graph of this one, okay, cool, 1, 2, 3, and here this is -1, and this, you know, this is -2. So this is the graph of fraction part of x, which is also defined as x minus gi of x, x minus gi of x. So here, you know, fraction part of x plus 1 is equal to fraction part of x. How it comes? Let's say example 1.3 fraction part. What is the fraction part of 1.3? That is 0.3, correct? And what is the fraction part of 7.3? The result is still you find 0.3. Suppose 2020 20.3, the result is that same 0.3. Okay, so these are the results. Anyhow, fraction part of x period is 1. Okay, this is the fraction part period is 1. Although root x, x square, x cube plus 3, these are not periodic function. Although not periodic function is called aperiodic. This is also called aperiodic. We see aperiodic. Let me note down aperiodic function. Okay, fine. So let's go some properties of the periodic function. The properties of periodic function is, first part, if fx has period t and cfx has also period t, it means, and f of x plus c, that is periodic with period t. Let's understand about this. If fx is periodic with period t and you multiply with any number constant c, then this is also periodic with period t. And here, if you see, then fx is, instead of in the domain x, if we see here x plus c, then still the period is t. It doesn't affect about this c as well this c. It's okay. And if you add this also plus minus c, then still is period with c. Period is t. It's okay. So we will take some example to understand. Suppose here fx equal to, if I see 5 sine x, 5 sine x. So as you know, the period of sine x is, what is the period of sine x? That is 2 pi. Here the power is odd, so period of sine x is 2 pi. So it doesn't affect about 5, as you see in the table what I have given the idea that cfx is periodic with same period. So fx is also periodic with period 2 pi. If you see here cfx, we are discussing about cfx, and now fx plus c about second one. So what we conclude here, let's say make some example. Let fx equal to, let me make a question, fx equal to, if you see as fraction part of x plus, you see as this fraction part of x plus, here you make as this one plus something pi. So what is the period of this? Of course, the period of fraction part of x is 1. Fraction part of x period is 1. So the resultant function is also periodic with period 1 as the fraction part of x. So that is, it doesn't affect what this pi we are adding over here. This pi doesn't affects. Let's see about this one. F of x plus c is also periodic. I'm talking about this one c part. Now f of x plus c. Let's we have some result over here as fx equal to, suppose if I say about this one, sine of, right, x, that was, I am talking about this one, x plus c. So that what we say here, okay, fx equal to, that is sine of x plus pi by 2 if I make here. So in this situation here, what I said here, if fx is periodic with period t, then here we say f of x plus c is also periodic with same period t, here, right, here in this case. So what about this one? Here we find that sin x period is sin x period of sin x is, that is 2 pi. So in case of sin x plus pi by 2 also, period is that same, that is period of fx is this one, period of fx is also, that is 2 pi, because that here pi by 2 doesn't affect, this pi by 2 doesn't affect, the period of sin x plus pi by 2 is also pi by 2 pi. Okay, fine. So let's take some more other also. If constant is added or subtracted or multiplied or divided in the periodic function, period remains same. So if you are adding any constant or this one multiplying or dividing, the period is same. Inverse of periodic function does not exist, but in case of trigonometric function, since domain and range one restricted and defined, hence inverse exists. Okay, here let me read once more, inverse this part. Okay, now fx is periodic with period t, then k into fx, or you say k into f of cx plus d has period t by mod c. This is very important for IT point of view. If you see here c, this part c, this is to be considered c as here, right? So what we say here, this is c, coefficient of x you have to divide by this is the period. So we say this is t upon mod c, hence this is the period. So we will take some example to understand this. So if fx, let's say fx equal to 3 sine of pi x plus 2, pause this and the video and get what is the period of this function. Guess about what the period of this function. Let's start. So now check the explanation. The period of sin x is 2 pi, but the coefficient of x is here pi. So what you have to do, as period of sin x is 2 pi, and but what we say here, x coefficient is pi over here. So you have to divide with this pi, and this is the period of fx. So period of fx will become here 2 pi upon pi. So the final answer will be, this is retaliated with this part here, pi and pi cancel, and then final answer is 2. So period of fx is 2. Final answer is 2. Although here this period is irrelevant of this 3. This is as like constant k is equal to f of cx plus any other constant d, you can say, some else. Let's see. So T upon mod C. Let's we take, if you want, you can take some more example about this. So let's say here fx equal to, let me take example of fraction part, pi into x upon pi plus root 2 fraction part. What is the period? Can you guess? So here this pi doesn't affect. What is this? Only this pi will be considered. So the result will be here. The period of fraction part of x, period of fraction part of x is, period of fraction part of x, we know that is 1. So what is here? So period of, that is fx, this fx, what we will write? We will write over here that 1 upon, that it mean that it is here we say 1 upon, you have to divide by coefficient of x. What is the coefficient of x over here? If you see, the coefficient of x is pi, so we have to divide not pi, the coefficient of x is 1 upon pi, so we have to divide with 1 upon pi, and the final answer is, that is pi. So the period of fx is pi over here. Okay, so let's we take some more example about this here. If you want, fx equal to tan of x upon pi plus 3 pi, right, and 5, like this. So what is the period of this function? As you know, period of tan x is pi. Fine. So period of tan x is pi, period of, let me write, period of tan x is pi. Okay. So what is the period of this function? So period of fx, that what we call here, we write as, here what you have to do, period of fx is, that is, you have to write pi, you have to divide this pi with the coefficient of x. What is the coefficient of x over here? If you see, the coefficient of x is pi, so you have to divide with 1 by pi as the coefficient of x is. So the final answer will be, here, that is pi square. Okay, so the final answer will be here, that is pi square. That is the answer. Anyhow, come to the point. Now this is the one more result is there. If fx and gx are the two functions with period t1 and t2 respectively, then here hx, mind this point, hx, note on, this says here, what is hx? Hx is here, that is a fx plus b into gx. They are the two functions here, that is a fx, okay, and b into gx. So you have to find the period of fx. Let's say the period of fx is t1, and here the period of gx is t2. Let's say here period is t1 and gx period is t2. Then what is the period of this hx? So the period of hx is the LCM of t1 and t2. That is the period. So let's see over here. If fx and gx are two functions with periodic t1 and t2 respectively, hx equal to a fx plus b gx, then hx has a period is equal to LCM of t1 and t2. You see, LCM of t1 and t2, that is important. So how to use this? We take example to understand this. Let's say fx be any function here, and let me write like this way, 5 sine x sine unit 2x plus 7, okay, and here minus 3 cos 5x plus 7, we say like this. So what the period will be? The period of sin x is pi. So what do you have to 2 pi? So what do you have to say? 2 pi upon 2. This 2 part. Period of sin x is 2 pi, and here with this 2 you have to divide. Right? This is one of the period, and later on it is pi. Anyhow, this one, if you see the period of cos x is once again that is 2 pi, but here what you have to do, you have to divide with this part 5, right? So you have to divide with 5, although this 2 and 2 related. So what we have to find, we have to find the LCM of this one. 2 pi means 2 related, pi and 2 by 5. So pi and 2 by 5 we have to find. Okay. So how to find this pi and 2 5? LCM of pi comma 2 pi by 5. So think about. So are you getting about this? Pi and 2 pi. So what the LCM will be? So LCM is simply here, that is pi. Our final answer will be here in numerator pi and 2 pi, that is the result will be pi, and here that is 1 and 5. 1 and 5, what do you have to do? You have to make the LCM of this, that is 1. In numerator you have to take HCF 1 and 2, that is pi, and in denominator what do you have to do? You have to take LCM, so that is pi by 5. Pi by 5. Okay. So let's take some more example, more illustration. Now, good point. In numerator you have to take LCM, and in denominator you have to take HCF. So that was the answer will be pi, no? Yes, the answer was pi. Let's see. So what over here, there are some exceptions to above results, that is mod sin x mod cos x period is pi. Mod sin x and mod cos x period is pi. Pi by 2 instead of pi here. So let's we take here, that is mod period of mod sin x plus mod cos x is pi by 2. Period of sin to the power 4x and plus cos to the power 4x is pi by 2 instead of pi, right? And mod tan x plus mod cos x period is pi by 2 instead of pi. Although if you go for LCM, then you will find pi, but the result is pi by 2. So you see here, and one more that is very important here, that is if fx is periodic with period t and gx is periodic, is any function, you say, such that the domain of f is a proper subset of domain of g, then g of fx is periodic with period t. Means inside the function period you have to consider, as like, let's take example here, fx, that we say sine of fraction part of x, sine of fraction part of x we say. So we know the period of sin x is, you say, period of sin x is 2 pi, while the period of fraction part of x is, that is 1. So which period is to be considered? So the period of fx is here, period of fx, that is not the period of sin x. We have to consider the period of fx is, that is the period of fraction part of x. So the answer is 1. Okay. So the period of this one fx is 1. Anyhow, so but sometimes if LCM is P by Q, R by S, T by V, U, like this way, then in numerator you have to consider LCM and in denominator you have to consider HCF. So, and here LCM of rational number with rational is possible, LCM of irrational with irrational is also possible, but LCM of two irrational number of different for example 2 root 3, 3 root 2 does not exist. LCM of rational and irrational also does not exist. So for example LCM of 2 pi, 2 and 6 pi is not possible. So such type of periods you say that the function is aperiodic function. Okay, fine. So in that situation, let's take some more example to understand this here. Okay, fine. So let's take example one here. Fx equal to let fx fine. So let's take example over here. Fx equal to let's we take some example to understand the HCF and LCM of this even and odd function and where the LCM does not exist. Let's see. So fx equal to, let's say 3 sine of 2x plus 3. Okay. And plus, okay, 5 into, say here, tan of pi x plus 2. Okay, fine. So if you see the sin x period is 2 pi, correct? That is 2 pi. And here what we find here, and tan x period is, that is pi. Okay. Then what we see over here, that is in sine the coefficient of x is here 2, so we have to divide over 2 here. But in tan, if you see, the coefficient of x is pi, so you have to divide with pi. So that is the result is you have to find LCM of 2 pi upon 2, that is 2 related, and pi upon pi, that is 1. So it means that is the LCM of that we say pi and 1. So what we can find? What is the LCM of 1 and pi? What is the result? So finally what we say, the result is aperiodic function. Okay. So if you want, I'll take some more example, and later on we'll go for some illustration also. Anyhow, so I'll wind up this lecture today. This much is sufficient. In the next day we'll discuss more on function and some illustrations and numericals on periodic function as well, even and odd function too. Okay, thanks.